This video is about a language that is in NL, and the language we are looking at is this video is about a language that is in NL, so that is decidable by a non-deterministic Turing machine in logarithmic space. And the problem we are looking at is path. And we claim path is in NL. So what's path? Path is you have a graph. So let's start with some graph. You have a node here. You have a node here. I call this one here A, this one B. You have a directed graph, so you have edges between the graph. Then you have a node C. You might even have a node D here. Can have loops. And maybe you have this one is E. Okay. So you have a given number of nodes and a graph and edges, and you have one source node. Let's say it's this one here, and you have a target node. Let's say E. And the path problem is the question, is there a directed path from source to target? And the question is there a directed path from source to target? Or more formally written, path. We encode it in these decision problems, so it's a yes-no problem. So this one is the encoding of a graph, source node and target node, such that G is directed graph that has directed path from S to T. S to T. Okay, so why is this problem in NL? How can we actually construct a Turing machine that decides this problem with logarithmic space? The first idea could be, I just depict first idea, or first try, is that we simply guess a path. So we guess a path, guess path. Because it's non-deterministic, we are allowed to guess. So we simply guess the path. Let's say the path that will work is A, B, C, and E. We write it on the work tape, guess path, and then check. Problem here is, this is not logarithmic. Here we have an example in which the path from the source to the target node is more or less, apart from this node D, the whole graph. And of course, I could have left D out, and then it would be more or less the whole graph. So this is not logarithmic in the size of the graph. It's more or less in O of n. So it's linear in the size of the graph. So this doesn't work. So we cannot write the whole path on the work tape. This won't work. However, actually we don't need the whole path on the work tape. The only thing that we really need is the current node, at which we are at some point in time. And what I will do is I will encode the nodes in, let's say, binary. So this is, let's say, node 1, this is node 2, so this is 3, this is 4, this is 5. And for the second try, we encode the current node on the tape. So what we'll put on the tape is the current node. Let's say we start with 1, and from 1 we go to, let's say, 1, 0, and we have the current node on the tape. This is encoded in binary. Coded in binary. So it's the number of the node. And what we do is we simply select non-deterministically one successor node in each step and update the current node accordingly. However, we have to ensure that the Turing machine actually terminates. So it's not allowed that the Turing machine gets in a loop. For example, here we could have a loop from A to B, then back to A and to B, and so on. So we have to prevent this. And to prevent this, we need a second counter. And this is a counter of the nodes visited. We also have to encode the nodes visited so far. And this also in binary. We know the total number of nodes, which is 5 in this case, and as long as the number of nodes that we have visited so far is below this number, we simply go on. Once we have reached the number, we stop. And that's the algorithm. So I'll write it down. So the idea is to store these two numbers. So we store the current node and the visited node. And we start with S as current node. And 0 as number of visited nodes. Then we select. Then we stop if T is found, and accept. We stop if if all nodes are visited. So if this counter here, then a count of the visited nodes is equal to the amount of nodes in the graph. And otherwise, we select non-deterministically a successor node of the current node. Update, then we update the current node and the count of the visited nodes. Current node and increment visited nodes. Increment the visited nodes. And that's a non-deterministic algorithm for deciding the path problem.